Okay, so in this lesson we're going to talk about piecewise functions, and in particular, in this part, we're going to talk about evaluating piecewise functions. So that's going to be the goal for this lesson. So evaluating piecewise functions. Now, you know what a function is, but you don't know what a piecewise function is. So as a review, let's talk about these two functions here. All right, so notice that this is a linear function, and so this function is denoted as f of x or y equal negative 2/3 x plus 3. All right, so that's the graph of this linear function. And the other kind of function that you graphed and that you dealt with was a quadratic function. And so this is the graph of this quadratic function. Okay, now let's talk about the fact that both of these functions, the linear function and the quadratic function, are continuous functions. So I'm using the words continuous, C-O-N-T-I-N-U-O-U-S. Okay, the word continuous. And so that means this: as I go from left to right, and so just think of these your pencil point here. So as you go from left to right, you're at no point are you removing the point, your pencil point, from this graph. So in other words, what I'm trying to say is you're continuously on this graph. Okay, you are continuously on the graph. You're tracing the graph. See how I'm tracing? I'm tracing the graph as I go from left to right. Same thing here. I am continuously on the graph. I'm tracing the graph as I go from left to right. All right, now I'm going to come back to that idea, the word continuous. So this is a continuous function. I'm continually on this paper. I'm continually tracing this path. I'm continually tracing this path, okay, as I go from left to right. Okay, now I'm about to show you a graph that is considered a piecewise function. Now this is a piecewise function. These are examples of piecewise functions. Now you're going to graph these in the next lesson. Now I want you to notice something. You see how this was f of x equal, and this is just one expression, negative 2/3 x plus 3. And you saw how over here f of x is equal one expression, just quadratic expression. Notice this, f of x equals a negative x minus 7, or f of x could be x squared, or f of x could be 6. See, that's three different functions if you think about it. Now, here's the idea. So, you see how f of x was equal to negative x minus 7? That's true only if x is less than or equal to negative 2. Here, f of x is equal to x squared only if the value of x that you choose is between negative 2 and 2. Notice that there's no equal sign here, there's an equal sign here. So that's going to be the idea of those open and closed circles. So you'll notice that in the graph you have an open circle, closed circle, open circle, closed circle. That has to do with whether you see an equal sign or you don't see an equal sign. And then over here, you're told f of x, y, remember f of x means the same thing as y equals 6 if the value of x is greater than 2. All right, so these are your domains, remember? So this function, depending on whatever part of the domain you're looking at, you're going to use one of these expressions. Now remember this, that the domain here, as you go from left to right, remember the domain's all real numbers, and the domain here is all real numbers. Remember, they are both polynomial functions, so the domain is going to be all real numbers. Now, Let's go back over here. As I go from left to right, I want you to notice I'm tracing the graph. So notice I'm tracing the graph. As I go from left to right, I'm tracing the graph. Now, you see there are 1, 2, 3 pieces of this graph, hence the word piece, so to speak. There are 3 pieces. 1, 2, 3. Each of those pieces comes from the parts of this function. So negative x minus 7, that's this right here. That's this part of this line. Now that's not a line because you don't see 2 arrows. All right, you only see one here, but that will be a ray. All right, not a line, because your domain is restricted only if x is less than or equal to negative 2. This part of the graph, this piece, comes from this one. See, it kind of looks like a parabola, right? Now it's not a parabola because you don't see an equal sign, but it's part of a parabola, right? Because your domain is restricted. You're only going from negative 2 to 2. And then notice y equals 6. That's a horizontal line. In this case, it will be a horizontal ray, although that endpoint here is open circle. All right, so the point so far is this. I need for you to recognize, see how many expressions, how many expressions make up this function? There's 1, 2, 3. 1, 2, 3. Okay? Now, as I go from left to right, when I get to that point, to get to this other piece, I've got to jump. And then trace over it. To get to the other piece, I've got to make a jump. All right? So this function right here is not continuous. So remember we said this was continuous, these two are continuous, because as you go from left to right, I never at any point picked up my pencil to go to the other part of the graph. This is just considered one graph, so to speak. All right? But when I get to here, notice I traced over it. To get to that part here, I've got to jump and then continue on. To get to this part here, okay, continue on. Get to this part here, I've got to jump. So we consider, if you think about it, you can consider these piecewise functions discontinuous functions. And you're going to hear more about that word in the next course. Discontinuous functions. All right? So these piecewise functions that we're going to look at, they're more than this one little expression. See how this function was one expression? One graph. See how this function was one expression? One graph. This function here has 3 expressions that makes it up. 3 graphs. Look at this. How many, before I show you, how many functions make up this, how many expressions make up this function? 1, 2. How many graphs do you see? How many pieces do you see? 1, 2. So that's the graph of this function. It's made up of 2 pieces. These 2 pieces come from your domain. So this says right here, if the value of x is less than 0, I've got to use this. If the value of x is greater than or equal to 0, I've got to use this. Same thing here. If the value of x is less than or equal to negative 2, I'm going to use this part of the function. If the value of x is between negative 2 and positive 2, not including negative 2, but including positive 2, I'm going to use this. If the value of x is greater than 2, I'm going to use this. Okay? Now, when we actually graph these, you're going to see why this is open, why this is closed, why this is open, why this is closed. You're going to see why is this open, why is this closed. Okay? All right. Now, what I want to do, though, in this lesson is talk about how to evaluate piecewise functions. So we're going to talk about evaluating piecewise functions. All right, so let's look at these examples. Example number 1. Okay, so first of all, recognize that this is a piecewise function because this function is made up of 2 parts. So the parts are this. So f of x will be 2x minus 5 if if x is less than if x is less than 4, excuse me, and then it'll be x plus 7 if x is greater than 4. All right, and you want to find f of 4. All right, now before I go on, let's kind of talk about this for a moment. So if I asked you, if I said find f of, let's say, 3 here, okay? Remember what you did to find f of 3. You went to your function where we saw the variable x, you substitute 3, right? All right, so you said negative 2/3 times 3 plus 3. Well, the 3's divide out. This is negative 2, and negative 2 plus 3 is 1. So you'd say f of 3 was equal to 1, right? Which means that when x is 3, y is 1. And notice that when x is 3 right here, that point here, y is 1. All right, so that's kind of a quick review of finding the value of a function at a certain x value. All right, now, this is what I'm asking. So I want to know, what is f of 4? What is f of 4? All right, so here's what's good to know. You can't just go to both of those now. All right, remember, this is your domain here. So your domain is made up of 2 parts. So you got to determine, well, first of all, which of these includes 4? Now remember, I want you to think about this part. So this says that any x less than 4, I'm going to use this. Any x greater than or equal to 4, I'm going to use this. Okay? So you ask yourself, which one of these is x equal to 4? Is x equal to 4 here, or is x equal to 4 here? So if I let x be 4 here, is 4 less than 4? The answer is no. Is 4 greater than or equal to 4? The answer is yes. So this is what I'm going to use. So if x is 4, I've got to use this function. So to find f of 4, you're going to use this function here, x plus 7. So you can say 4 plus 7, which is 11. So f of 4 equals 11. Let's go to the next one, f of 6. So ask yourself, am I going to use, is 6 in this domain or 6 in this domain? So in other words, if x is 6, and you notice x is here, is 6 less than 4? The answer is no. But then ask yourself, is 6 greater than or equal to 4? The answer is yes. So which of these two expressions are you going to use? You're going to use this one again. So you're going to say f of 6 will be 6 plus 7, which is 13. So f of 6 equals 13. Which means this, which means that when x is 6, y is 13. This means that when x is 4, y is 11. Okay, now let's look at this one, f of 0. So ask yourself, remember x is 0 now, is 0 less than 4? The answer is yes. Now you're not going to use this one because you're going to say, is 0 greater than or equal to 4? The answer is no. So you're going to use this one. So now you're going to, for f of 0, you're going to go to this expression now. So you're going to say 2 times 0 minus 5. 2 times 0 minus 5. 2 times 0 is 0. 0 minus 5 is a negative 5. So f of 0 equals negative 5. So meaning that when x is 0, y is negative 5. And that's how in the next lesson you're going to be graphing these functions, these piecewise functions. All right, now I want you to think about this. All right, so let's look at this one now. F of negative 3. So think about, am I going to use the function, I'm going to use the expression 2x minus 5, or am I going to use the expression x plus 3? You can't use both, otherwise it wouldn't be a function, because you'd have two different y values. Remember, a function, for each x coordinate, there's got to be one y coordinate. So again, you can't go to both. You got to determine which one of these is going to apply here. So you're looking for what's the y value when x is negative 3. So is negative 3 in this domain, or is negative 3 in this domain? Well, negative 3 is in this domain, right? Because this says that I'm going to use all the x's, that I'm going to use this expression if the x is less than 4. And negative 3 is less than 4. So that's when you're going to use. So you're going to say 2 times negative 3 minus 5. And 2 times negative 3 is a negative 6. Negative 6 minus 5 is negative 11. Okay? All right, let's go to the next one. All right, now notice that this function again is made up of two expressions, so two pieces. So when I graph this, you're going to see it's going to have two pieces. Now, the fact that this had no equal sign and this has an equal sign has to do with those open and closed circles that you saw. Open circle, closed circle, open circle, closed circle. All right, it has to do with that. Okay, now all I want to do though is just evaluate this function. So let's think about this one. So notice this says that that y, g of x, is going to equal x squared plus 2 only if x is less than or equal to 0. Y, or g of x, is equal to 4 only if x is greater than 0. Okay, so let's look at this now. G of 0. So I want to know what's the y value when x is 0. So ask yourself, do I use x squared plus 2 or do I use 4? Well, if x is 0, which one of these applies? Let's look at this one for a moment. Remember, x is 0, so in place of x, put in 0. So ask yourself, is 0 greater than 0? No, 0 is not greater than 0. 0 equals 0. So I'm going to use the one that has the equal sign in it. So that's going to be this one. So you're going to say g of 0 then will be 0 squared plus 2. So where we see the variable x, you substitute 0. And 0 squared 0, 0 plus 2 is 2. So g of 0 equals 2, meaning that when you graph it in the next lesson, when x is 0, you just found your y value. My y value is 2. All right, let's go to this one now. G of negative 3. Well, ask yourself, am I going to use x squared plus 2 or am I going to use 4? Well, if x is negative 3, let's look at this one. Is negative 3 greater than 0 or is negative 3 less than or equal to 0? Well, negative 3 is less than or equal to 0, so I'm going to use this one. So this is going to be negative 3 in parentheses squared plus 2. Negative 3 squared is 9. 9 plus 2 is 11. So g of negative 3 is 11, meaning that when x is 0, y is 11. Let's look at this one, g of 2. All right. So this time, what is the x value? What is the x value that I'm interested in? 2. So I want to know what's the y value when x is 2. Am I going to use this one? Or are you going to say that g of 2 will be 2 squared plus 2? Think about it. You better say no, because I want to know, I want to use the 1. I need to use the domain that works here for x is 2. When x is 2, is 2 less than or equal to 0? No. 2 is greater than 0. So I'm going to use this one. All right. Now, don't let this throw you off. You graphed things like this before when y equal 4, when there were no variables. Remember, if there's no variables, it's a constant, y equal 4 is that horizontal line. Remember that? Okay. Now remember what that means. That means that y is equal to 4. In fact, y always equals 4. All right. So remember when you graph this, I want you to think about this. Don't let that throw you off. So when you graph this, let's say y equal 4. When you graphed it, remember what that means. When you use the t-table, that means that y always equals 4 no matter what x is, right? So when you graphed it, just this right here now, you get 0, 4, 2, 4, and you got this horizontal line. And notice that no matter what your x coordinate was, your y coordinate's always equal to 4. Y was always equal to 4. Always. So what I'm saying here then is this. If x is 2, then what's g of 2? Well, g of 2, I'm going to use this one because 2 is greater than 0. G of 2 will equal to 4. That's it. What about g of 7? Which one do I use? Is x equals 7 in this domain, or is x equals 7 in this domain? Well, it's in this domain. So what's g of 7? G of 7 is also what? 4. Okay? All right, let's look at 3. All right, now notice that in 1 and 2, you saw you had those inequality symbols, less than, greater than, equal to, less than, equal to, greater than. Here you have that not equal to symbol. Okay? All right, so let's think about that for a moment. All right, now, this piecewise function has two parts to it. I use this expression if x does not equal negative 4. Okay? I use this expression if x does equal negative 4. All right, so let's look at this one. H of negative 4. So I'm going to ask you, if x is negative 4, which of these domains apply? Is it this one? Because this says if x is negative 4, is negative 4 not equal to negative 4? No, negative 4 equals negative 4. So I use this one. So h of negative 4 will be, I'm going to use this piece. So you're going to say negative 4 plus 4, I'm sorry, plus 6 rather. Negative 4 plus 6, which is 2. So that means that when I graph this piecewise function in the next lesson, that would mean that when x is negative 4, my y value would be 2. I plot that point. What about this one, h of 6? All right, now remember what that means. See, you have a not equal to symbol here and an equal symbol here. What that means, remember what that means is this, is that you're going to use this expression if the value of x is not equal to negative 4. You're going to use this expression if the value of x equals negative 4. Well, x is 6. Is 6 equal to negative 4? No. Is 6 not equal to negative 4? Yes. So you can use this one. So you're going to say 6 squared minus 16 divided by 6 plus 4. And then 6 squared is 36. 36 minus 16. 36 minus 16 is 20. And then 6 plus 4 is 10. So 20 divided by 10 is 2. So h of 6 equals 2. Okay, let's look at this one. H of negative 2. Which of these applies? Is negative 2 in this domain or is negative 2 in this domain? All right, let's think about this one. Is negative 2 equal to negative 4? The answer is no. Is negative 2 not equal to negative 4? The answer is yes. So you use this one. All right, so you're going to say negative 2 squared minus 16 divided by negative 2 plus 4. Negative 2 plus 4. And then negative 2 squared is 4. 4 minus 16 is a negative 12. Negative 2 plus 4 is a positive 2. And negative 12 divided by positive 2 is a negative 6. So h of negative 2 would equal, and in a blank you would say, negative 6. All right? Now notice, I want you to notice that well, let me go ahead and do this one. H of 0, and then I'll come back. H of 0. When x is 0, or am I going to use this domain or this domain? Well, h of 0, ask yourself, is 0 equal to negative 4? No. Is 0 not equal to negative 4? Yes. You're going to use this piece now. So you're going to say 0 squared minus 16 divided by 0 plus 4. And then 0 squared 0. 0 minus 16 is a negative 16. 0 plus 4 is 4. And you get negative 4. So what you found is this. H of 0 equals negative 4. So when you graph this in the next lesson, basically you're going to be plotting the point when x is 0, y is negative 4. Okay, now notice that when was the only time I used this expression? When was the only time I used this one? Well, the only time I used this one was when x was equal to negative 4, and that was this one. Everyone else, all these other parts, you would use this one, because that's the only one, this right here is the only one where x equals negative 4. All right, so this is evaluating piecewise functions, so it's not a difficult thing. You're going to use this idea, though, in the next lesson when we graph piecewise functions. So when you graph these, and basically in the next lesson you're going to be graphing a function with two parts. So just be two pieces. Okay? And we're going to talk about open circle and closed circle. Why is this open? Why is this closed? And we're going to come back to this idea also. All right, so that takes care of evaluating piecewise functions.